Thank you. And thank you for having me here. Argumentation has recently gotten increased attention within artificial intelligence, mainly because of its connection to other areas of artificial intelligence, like a non-monotonic reasoning, game theory, and knowledge representation. One of the widely used and studied frameworks for argumentation is abstract argumentation framework introduced by Dung, or AFs for short. And this framework can be represented as a directed graph in which node shows arguments and edges shows a direct attack between arguments. The main power of this framework is behind the semantics of these frameworks, which represent a point of view of acceptance of arguments. And most of the time they are introduced based on extensions, and extension is a set of jointly arguments. For instance, stable semantics represent the black and white perspective of accepting arguments with a stable extension that attacks all the arguments which are not belongs to the set. Here in this AF, we have two stable extension. Assume that I add only one argument to this framework with a self-attack. It seems that adding just one argument with a self-attack shouldn't have that much effect on the semantics of a given AF. However, we see that this AF do not have any stable extension. In AF, the notion of semi-stable semantics has been introduced to approximate stable extension when there is no stable extension in a given AF. Despite the importance of AFs in argumentation theory, the expressiveness of AFs is sometimes too limited because they can only present attack relation between arguments. Abstract dialectical frameworks introduced by Verbrugge and Wolfram can assumed as a powerful generalizations for AFs that can represent different type of links between arguments. And I return back to the formal definition in a few minutes, but first I present what was the motivation of our work. The notion of a semi-stable semantics for AFs have been introduced first by Verheij and later on by Caminada, and the properties of these semantics has been studied. And for instance, it's proven when for any finite AF has at least one semi-stable extension. However, this type of semantic has received little attention in ADFs. Thus, it was a motivation for us to introduce the notion of semi-stable semantics for ADF. We studied properties of this type of semantics in our work, and we showed that the semi-stable semantics for ADF is a proper generalization of the same notion for AFs. In the following, first I present a brief background about ADFs, then I explain the notion of semi-stable semantics for ADF. I show some of the properties that are proven in our work, and at the end I will present a summary of our work. Here I turn to present the formal definition of ADF. An ADF is a triple in which A is a finite set of arguments, L is a links between arguments. However, the meaning of links here are very flexible to support, attack both of them or neither of them. And this is done by adding a propositional formula to each argument, shows that what is the acceptance condition of that argument. And semantics of AFs mainly defined based on three-valued interpretation and with the help of characteristic operator. A three-valued interpretation is a function that assigns each argument to true, false, or undecided, and it is called two-valued if each argument is assigned either to true or false. Sorry. A characteristic operator takes an interpretation and revise the information of that interpretation to V prime by evaluating the acceptance condition of argument under a given interpretation. An interpretation is called complete if it exactly contains justifiable information, and it is called grounded if it presents the information about arguments that no one has any doubt about them, because it is the least fixed point of the characteristic operator. Actually, the notion of stable semantics of AFs has two generalizations in ADF. One of them is two-valued model semantics, and the other one is a stable semantics. Actually, each model is a complete interpretation, which is also a two-valued interpretation. Each stable interpretation is also a two-valued model. However, each stable interpretation clarifies a support cycle among the arguments. To this end, we collect all the arguments which are assigned to true in this interpretation. We reduce our framework and we check whether there is a constructive proof for each argument which assigns to true. That is, whether each argument here belongs to the grounded interpretation or not. I explore the difference between these two notions in an example. For instance, this ADF has two-valued model, and I will show that which one is stable. For indicating which one is stable, we reduce the frame with our ADF to two ADFs, and we check whether the arguments which are assigned to true here are in the grounded interpretation or not. For the first case, it's satisfied, therefore V1 is a stable model, but the second one is not satisfied, therefore V2 is not a stable model of this ADF. Now I turn to the main part of our work, in which we define the notion of semi-stable semantics for ADF. There exist two reasons that an ADF may have no stable model. First, it's possible that ADF has a two-valued model, but none of them is a stable model. It means that in each model, there is a kind of support cycle among the arguments. Therefore, the set of stable models are empty. There is one further reason that if an ADF do not have any two-valued model, then it won't have any stable model as well. To introduce the notion, we focus on the second issue, and we defined our definition in this case. To this end, first we approximate the models of an ADF. That is, first we define the notion of semi-two-valued model that picks an interpretation, checks if it is a complete or not. If so, then checks whether the arguments which are assigned to undecided are minimal among the all-complete interpretation. Then it is called semi-stable if it doesn't contain any support cycle among the arguments. I show different type of semantics in this ADF. This ADF has three complete interpretation. In each of them, at least an argument is assigned to undecided. Therefore, none of them is a two-valued model. It means that this ADF do not have any stable model as well. However, by our definition, both these two interpretations are semi-model of this ADF, and we check which of them is a semi-stable model of this ADF. To this end, we construct our ADF based on this interpretation. Here, the structure of our framework do not change. Then we check the grounded interpretation of this ADF, and since it is not equal to it doesn't contain B and C, therefore V1 is not a semi-stable model of this ADF. Now I turn to check whether V2 is a semi-stable model of this ADF. I construct the ADF based on V2, we reached to this reduction framework. And as we see, this no argument assigns to true here, and the grounded interpretation contains no argument as well. Therefore, V2 is a semi-stable model of these ADFs. This example shows the distinction between different type of semantics of ADFs. It shows that semi-stable models is actually differs from stable semi-to-valid model, preferred and complete semantics of ADFs. In our work, we studied the exact relation between these two types of semantics and the existing semantics of ADFs. We show that every ADF has at least one semi-stable model. However, it is not the case for other type of semantics. We proved that if an ADF has a stable model, then it is the set of stable semantics and semi-stable semantics are coincide. And we showed that this notion actually is a generalizations of the same notion for AFs. We have further results. I don't know if I have any further time to explain them, but as a conclusion, I would like to say something about the summary and future work. In summary, we explained two new type of semantics for ADFs. We studied the relation of these two type of semantics with the existing semantics of ADF, and we proved that these two notions are equal in the associated ADF of a given AF, and the reason is that in AF we do not have any support link. As a future work, we would like to study the computational complexity of the reasoning task under these two type of semantics, and we would like to introduce new type of semantics for ADFs, for instance, idle semantics, which hasn't been studied yet. Thank you for your attention.